is simply, really is not going to be much different than what we did in some previous sections. Okay? If you'll remember, draw yourself two lines congruent. I'm sorry, two lines that are parallel. Then draw yourself a transversal. Then number them. The angles, that is. Now, one thing you've got to understand here when you look at this is, do you remember what did I say? When is 4 congruent to 6? When what? When L is parallel to what? Right? Okay. 2 and 6 are congruent when what? L is parallel to M, right? Look at the heading of this section. Proving lines to be what? So instead of saying these two are parallel, therefore 4 is congruent to 6, we're going to go the other way and say, hey, guess what? 4 is congruent to 6. So what do you think that says about L and M? They have to be parallel. Do you see what I'm saying? See how we're going the opposite direction? Instead of saying because these two are parallel, this has to happen, we're going to say, hey, guess what? 3 is congruent to 5. Well, since they're alternate interior angles, if a set of alternate interior angles are congruent, then I know that these two lines have to be what? So, we've got a bunch of kind of theorems we're going to kind of simplify here. So I'm going to say if alternate interior angles are what? Congruent, then the lines are what? Parallel. Would you guys... What else do you think I could say? If alternate what? Exterior angles are congruent, then what? The lines are what? Parallel. What else? If corresponding angles are what? Congruent, then the lines are what? Parallel. Last one, if consecutive interior angles are what? Supplementary, then the lines are parallel. Isn't this basically just the converse of what we learned in section 3.3, I think? Or 3.2? 3.2? So if I can find any one of these sets of things to be true, what can I say about the lines? They have to be what? Parallel. There's also a theorem. Well, I'll wait till everybody gets that written down. We got it? Hey, turn off one of those lights again. It does shine a little. See, it's easier for everybody to see when we turn one of those out, isn't it? Well, maybe. Now that's better. Thank you. All right. Okay, they have another theorem in here called the parallel postulate, which all it says is, say you had this line right here, M, and point P. How many parallel lines do you think I could draw through P? What do you guys think? Well, let me think of the protractor as a line. That one's not parallel to M, is it? That one's not, that one's not, that one's not, and then you get to what? Right there, and then what? That one's not parallel to P, right? Then I keep going around the circle, that one's not, that one's not. As you can see, if you keep going around, there's never going to be another one except for what? That one right there, and that's what the parallel postulate says. It says that if you have a line, and you have a point not on that line, there's only one possible line that you can draw that's what? Parallel to M, okay? As you can see in these theorems, they call this the converse, alternate exterior angle converse. You know, if you can find one of these angles, alternate exterior angles to be congruent, then you know these have to be what? Parallel. If you can find one set of consecutive interior angles that are supplementary, then those two lines have to be what? Parallel. So on and so on. You only need one set. Look up, look up. All right, let's get our little red books out. Do a couple examples. Okay. Given the following information, determine which lines, if any, are parallel. State the postulate theorem that justifies your answer. 3 and 7. So let's look at 3 and 7. So here we are, 3 and 7. Which two lines would be parallel there? So A would be parallel to B. Why? How does 7 relate to 3? Huh? Are they alternate interior angles? Because basically we're looking at it like that, correct? So you would say alternate interior CONV for what? Converse. Wake up, please. Angle 9 and 11. 9, 11. Which two lines are parallel here? That determines that A is parallel to B. By what theorem? How does 9 relate to 11? Corresponding angles. So corresponding angles what? CONV period converse. Let's jump down here to number 4. Measure angle 5 and angle 12. Add to what? 180. Does that help us? Which lines are parallel now? L would make L parallel to M. Why? Consecutive interior angle what? Converse. Any questions there? Let's look at this one right here. Let's look just at number 5 right now. Okay. It says find x so that L is parallel to M. So what are they saying to us? That basically find x, which would make that parallel to that. So isn't that just like some problems from section 3.2? How should this angle relate to this angle? What are they? They're either what? Alternate interior angles? Consecutive interior angles? Corresponding angles? Or alternate interior exterior angles most likely? Which one are they? Consecutive interior. What did I tell you guys? When you have this situation, they're on top or beside each other, how do they relate to each other? They add to 180, correct? So, for number 5 here, how would I write that? 2x plus 6 plus what? Is equal to what? And now it's just a matter of solving, isn't it? Any questions so far what I'm doing? Is that correct? Everybody look at that. Any questions? Let's look at number 8 here. Pencils down. I'll let you write these two after we're done with 8. We're going to make these to where these two are parallel. How does 4x relate to x plus 6? Which one are they? Alternate something. What? Alternate exterior angles. How do they relate to each other? They're congruent. So what can I say? What am I going to do? Subtract x? What's x equal to? Quick, write that down. We'll do one more. Everybody got that down? All right, let's look at number 9. This one's a little tricky. Can anybody tell me why? There we go. Do these angles with information that was given to us, do these relate to each other in any specific way? I mean, are these two alternate exterior angles? Are they corresponding angles? Top right, top right. No, they're not. This is top right, this one's bottom right, correct? Are they consecutive interior angles? No. Are they alternate interior angles? They're none of those four, are they? So at this point, we need to be a little creative and say, well, what do we know though that happens in this situation? This angle is congruent to what? Which is congruent to that angle, which is congruent to what? This angle is congruent to what? This angle, so on and so on. So if this one's 7x minus 5, what's this one? And if two angles are beside or on top of each other like this, how do they relate to each other? So that's how those two relate to each other, isn't it? Okay? So what would my equation be? 7x minus 5 plus what? All that would equal what? $12x plus 14 is equal to 180. Will go into that, what, 1 with 4. What you guys get as an answer here? Did I write that down correctly? Yeah, but it just doesn't come out even, does it? What is 166 divided by 12? Okay. Usually they come out a little cleaner than that, but I guess that one didn't. Any questions there? Write that down.